Hello everyone and welcome back. In this video, I'm going to go over the background. So with that said, let's do this. We're going to cover the background on this video. So using the Nerdy Nights Mirror website as your main source. And I said in the previous video that I was going to also cover how to make the graphics for the NES. But I decided to make that in the next video. So I'm going to show you guys how to make it, as well how it works. And putting that in this video will make it a lot bigger than it needs to be, and I think it needs to be its own separate subject. So this video just how to make the backgrounds for our NES games. So to help that, I already have running our Mega Man. I have pause over here, and here is our background for sprites and everything going. So how we make this happening. So to do a background, there's three major components that we need to worry about. That's the background palette, the name table, and the attribute table. So the background palette is pretty much the same as the sprite palette. And to help demonstrate that, let's go under PPU Viewer, Palette Viewer, and here's a background color that we can use for our background. Here's the sprite. So if you've seen the sprite video, it's pretty much identical. So if I change a color over here under the PPU Viewer, let's say this is just yellow, it automatically updates our emulator over here with this yellow color because that's all the colors that we can use for our background. So if I change this for red, you see it's red. If I change this to black, it becomes black. Let's just go back to a blue. It doesn't matter what blue over here. This is maybe too dark. Here you go. No, I'm satisfied. It's supposed to be 2C, but that's fine. And if I change, let's see, there's a red over here. If I change this red over here, as this is going to change everything over here as well. So keep that in mind. And pretty much like in the sprite video, if I change this first color on this row over here, you're also going to change this color for the sprite because it's transparent color. So that's the color that the sprite and the background are the same color. So that's going to be set as a transparent color. So the background won't stand out. And it's all going to be the same. As you see, as I change the background, and vice versa over here, it changes the not only the emulator part, but also the first palette in the first row over here, which is row 0. And of course, if I do the same thing for row 1, which is the second row, the same thing happens, and so forth with the other rows. So just keep that in mind. The transparency color, and that's all there is about the palettes. Even though it says 16 colors, the first colors of each of this is set for the transparency color. So it's a little bit less than that. So that's the colors. Let's close this. And next up, we have the name table. So if I go over here under PPU Viewer, you see right away here, you have a name table viewer. And you see a bunch of, let me try to turn it, so check this out for now. And you see the same picture happening over here. And that's because the image is being mirrored. The type is vertical, but I couldn't cover those later. All we need to know is that there's this part over here. There's one picture over here. This is the main display happening is right in this one. So let me click times 2 so you can see a little bit better over here. And I can click here on show tiles. And as I scroll over here, it doesn't matter which ones, this is being mirrored. But the screen is going to change where it goes. So let me use this one. You can see this top position right over here. On the top right, you're going to see all the information that we need. So in position 00, we have our tile, which is a 04. So if I come under here on character viewer, it has all the characters files. And our background2.asm, which you can download over here, .zip file, is going to contain the Mario background files. Should I say the graphic files, which you do right over here, not only the graphic files, but as well the sprite file. Right here, include Mario Kart. But in Mega Man, if I come over here, and we come up under character viewer, remember I said before in the NES there is a program, PRG, for the code in your character viewer, which contains all the data. So there will be the data right over here for both of them, for the sprite and for the background. As you see over here, all of this, let me put ×2 so you can see it a little better. All of these tiles over here is being displayed on the screen over here. So if I come over here, ×2, come under this part over here, see on the top right. So this is position 1012 and tile 08. So if I come over here, 08. So this is the tile for the stair over here for the left side, and probably 09 is going to be the 08 is going to be to the right side over here. So 08, 09, 0B. Which one was it? I said. This is 0A. Okay, so 8 and A. So as you see here, that makes up this this first part of your arbor ladder that we can climb up or down. And it's easier if I have here show tile grid. So a background is made of 32 by 30 tiles, but in sequential order, as you see over here. All of them is going to have a separate tile number. So you're going to, so this one's like put tile 4 and then put tile 6, put tile 4, 6, 4, 6, 4, 6, repeating the same everything all over here. So let's see. Like sprites, background image is made by 8 by 8 pixels per tile. So if I come over here, a single tile here is 8 by 8 pixel. And the resolution is 32 by 30 tiles, like I mentioned before, or 256 by 40 pixels, which corresponds to almost 1,000 tiles, like 960 tiles altogether. But the only thing that I have to keep in mind is the PAL system is going to show the whole resolution and all the tiles. But the NTSC version, or the North American version, is going to crop the top 8 and the bottom 8 rows of the pixels. So it's a little bit lower the horizontal over here image. So this is 256, this is 224, this is 240. So it's a little cropping version. So keep that in mind whenever you're making our game to the corresponding system over here, either PAL or NTSC. So full background is nametable, as you see before. And the NES has an internal memory of RAM to have 2 names table. As this, you can add a little bit more, not only later on adding another mapper, which could use the workable RAM or the inside RAM of the chip. So you can have more than that, but as it stands as is, if nothing changed, you can only have 2 name tables. And as you see over here, name tables generally mean just 2 different screens, 2 backgrounds. So here you have 4 happening over here. And a name table has 1 byte, so 0 to 156, for each of the 8 tiles of the graphics shown on the screen. So the PPU starts at address 2000 and takes up to 296 bytes. So that's all the tiles all together. And if you go up here to, which week was it? Right over here, you can see here is the cartridge ROM. So all the tiles for different tables over here. And this is name table. So that's our first screen. This is the second screen. And this is the third and fourth. And this is the attribute table, which is going to cover next. So if you ever work with any RPG maker, you know how to make those. It's pretty much all layout of different tiles. And the part with everybody has the most trouble with, this is the attribute table. It's right over here. It's the most difficult thing to understand. But it is because of the limitation of the NES over here. You also have here open the name table under the NES Dev Wiki site. You have its own attribute tables. So let's go over it. begin over here. So let me start with Megaman. Here is our tile grid. So let me turn this off and let me show you the attribute grid right over here. So as you see over here, you have a 2x2 over here, and I can change pretty much the color of this whole 2x2. I can set one set of colors over here, and you can see right over here. Well, this is all of those using palette 1 is almost the same attribute. Now let's come over here. I can see a little bit of diversity happening over here. So here is all the different colors, and you see right over here there's a different set of colors over here. So you can see on the attribute table, all of them are still the same. So this is attribute 55. This is the same 55. And here's 0, 0, this is 0, 0, and then 55, 55. So the attribute is going to pretty much change which row of pallets we're going to use. So normally, as you see over here, is only pallet 1. And as I scroll over here, there's pallet 0 over here. So let's see what else can I do. So this is pallet 2, so different colors. And we can go up to 3. I think you're really using 0, 1, and 2 pallets over here. But let's go over here and show you guys how it works on the Nerdy Nights, because it has a little bit better highlight over here. So each name table has an attribute table, which seems to set which colors the pallets would be used. So that's pretty much what it is. We're going to divide the screens, and we're going to set these colors over here. And the attributes table is sorted internal RAM, which I showed you guys before on the memory mapping for the internal RAM right over here. So here is the screen name table, and right on top you have our attribute files, which begins at least on name table 0 at 23C0 and end at 2400. Pretty convenient. So let's go back to the background over here. So first, the screen is divided by 32 by 32 our pixel grids over here, or 4x4 tiles. Each of them has an attribute set of tables between the group 0, 0, and 3. That's what I showed you guys before. If I show you attribute pallets 2, here's 0, 1, here's 0. I'm using the last one, but you have the 4 rows to work with. And the 4x4 area is divided again by 2x2 grids over here. So the complicated part is there's this big chunk over here, and then it's divided once again to this small section over here. So you can see better in this picture over here on Mario. So this question mark and brick area, which is only this two over here, as you see the mouse hovering over them. So this is a big chunk over here, which is a 32 by 32 pixel area, and it's divided once again over here. And within this tile set over here, we can set different color palettes to them, as you see over here. So let me open this PPU under the NES to demonstrate a little bit better. And the same thing, so here you can see actual the background happening over here. So you'll see 0, and here is our screen for this game over here. And the only thing, and I'll show you this part. This part is kind of like important, which is not discussed on the Nerd Nightmare. And I can show this as well on the emulator. So let me do the emulator. So right over here, I have let me just go over here, debugger. Let's go under memory tools over here. Let's go under our PPU memory. Okay, so under their PPU. And I know it's going to begin over here in the 23C over here, which it does tell us 23C for the name tag 0. So let's go over there. Let's scroll down, all the way to 23C0. So this is 23. This is 23C. Oh, here it is. So here is the name table. So let's come up by you. Let's come over here. And let me change this part over here. So this is tile location. Let's see if this is 20. Where is it? This is 20. As you see over here. And another thing, you can check which mirror this is position 2. So that's the name table 0. Just notice that this is 24. And if you come over here, I'll show you guys. So might as well explain right now. So this is from 2000 to 23. That's name table 0. So 24 to 24/7. That's name table 1. So that's the second background. If I come over here, so here is the tile. This is 28, which should be over here. Where's 28? So that's name table 2. And if I have the 200C to 2F, that's the third name table, or the fourth one. So as you see over here on this mirror, good thing I just forgot to mention. So that's all the different name tables or different screens happening at the same time. So here you see there's 4 happening. And go back over here, which is the main focus that we want to change. If I come right over here, not only can see on the top, the bottom right, but can also see the tile info all the way to the right. And I know this is a location, it says like attribute 23D4, and that's 00. So let's go over here. Let's open everything at the same time. Memory tool. So let's go. Oh, 20. Just forgot. Let's see. 23D4. Okay, let's go over here. 23D400. Pretty easy to see. And let me put the value 55 over here. And as you see, I changed the whole thing over here. Pretty easy. If I put 00. Oh, I changed. Wrong guy. Not 05. It's 0400. Let's go back to where it was. And to change, as you see over here, this 2x2 section has one set of color. That's 0. This is 0. This is 0. This is 0. Makes sense for this game if we want to keep consistency. But let's change a color of each over here. And to do that, let's go under PPU name, under the NES dev over here. And here we can see how to change that. So here is a byte. So the first 2 least significant byte, I'm going to change the top left. The other 2 over here in this order is going to change position. So this is 0, 1, 2. Position 3, 4 changes the top right. So this was top left, top right. And the position, so 5, 6 is going to change the bottom left. And the most significant bit, the last 2 is going to change the bottom right. So let me just put a, let's see, binary to hex, help me out over here. Rapid tables, I do that all the time. Okay, so the least significant byte, since we have 4 pallets to work with, say pallet over here. So we have row 0, row 1, row 2, and row 3. So let's change the first one to be row 0. So that's pretty easy. Well, let me go here on the hex. So it's going to be 0, 0. Pretty easy. Then let's do in order. So let's 0, 1. So that's row 1. Then row 2, and this one is going to be row 3. So let's convert it, see what I get, E4. So we'll come over here, instead of 0, let's put E4. So let's go to our over here. And as you see over here, I get almost the same color. So let me just change this over here. It seems to be the same. So let's put this color over here. Just separate, and this is black. So you see over here under this 1 byte, I was able to manipulate this boulder right here on the top of this top of this roof, let's say. And within 1 byte, I can manipulate this 2x2. I can further come over here and come on this. Not only is the attribute, I can show the tiles over here. That's gonna be like too much. Let's keep an attribute over here. Take the grayscale. Okay. So there's 2 tiles over here. So there's 1, 2, 3, 4, the 2x2. And by changing this is the what? This is the top left, which is top left is the least significant bit. So that's color 0. And then this is the top right, which is the next 2 over here. So this is the pallet 1. And here the bottom left is the pallet 2, and this is pallet 3. So as you see, this whole attribute, even though it's split over here, 1 byte is going to change all of this. And there's going to be some games which you're going to see some, because of these limitations, we're going to have to not only set up our map, our namespace over here in mind, so you can keep everything together, which they did for Mega Man. There's some of them which you can see some of this going on, and that's because of this limitation. But that's pretty much how you work with the attribute table. The only thing, even though I clicked on here in the attribute grid, a whole byte is going to take this whole section over here. And then you divide it one more time. So see, it's very grid over here, 5 tiles. So 1, 2, 3, 4, 1, 2, 3, 4. So a whole byte is going to change all of this, but by each 2 bits over here, we can change the whole colors over here. And as you can see under this NES dev over here, you can show you this part, which you can also see over here. So let me come over here. Let me bring it up over here. So show attribute grid, show attribute colors only, as you see over here. It's a little bit harder to distinguish than this one. Is very nicely laid out over here, and you can notice all this part. But the major thing, which is not on the website, is the equivalency value over here. So that's how the whole background things work. So let's go over just the background.asm. So here's the code. Here's what we have. So let's go back to the background. So here it is. The easy part over here. So already understand how everything works. So all we do over here first, here we have a loop over here. Does it go? Yeah, all right, it's the same thing. So let's just keep the Visual Studio Code open. So here you have our loop for the background. And pretty much like the sprites, we make sure we set the high to low latch so we can actually give the address 2000. So, and we're gonna write into this PPU port over here, 206. And here is how you get your PPU ready to accept the background. Then you have another loop over here. That's why I click enter over here. You can see. So this is our counter. We start at 0. We're gonna load our background, which is right over here, which contains all the. Here is the background or our map, we just say, for this game, and it was put manually over here. I'll show you guys later how to create a map using some other software. But in the case for this tutorial, it's already laid out over here. So here, so use this tile, this tile, this tile, this tile, as you see over here, row 1, all sky, and so forth, as you see over here. So where was I? Oh, I already passed by. Attribute, background, here it is. So load all these tiles, and this is increment Rx, and store that to this PPU port. This is gonna set the tiles, and it's pretty much standard for it. So once you reach 80, so in this tutorial we only have 80, then it's done. I already have filled our background, even though it's not gonna fill the other way, but that's how it's gonna happen over here. And here we're gonna load the attribute right over here. Same thing. You're gonna set our latch high to low, and then you're gonna write at the PPU address for this port 2006. Just set this to start at this location over here. So you have here 23 and C. That's where we're beginning to their attribute tables, and pretty much like before, you have a attribute right over here, essentially the same. So you're gonna write at this is the PPU port to write on that location, and here I have just 8 attributes over here. So here is the background, so our map, and here's the attribute that we have right over here, and this is the color scheme for our background.sm. So let me close this. So Mega Man did our purpose. Thanks, Mega Man. And if I run task, compile, make sure everything. Oh, something is wrong. Why? Background. What did I change over here? You know what? Let me just. Sometimes I'll play around with this. Let me just open this, copy this over here. Let me just, oh boy, open Actual Visual Studio instead of Visual Studio Code. But I guess it's, let me go back over here. Let me copy this, paste over here, so everything as this. Let's compile this one in time. Okay, everything worked. Perfect. Let me close Visual Studio Code. And Visual Studio. So run task, run an emulator. And here is all of this over here. That's all the map that's happening over here. This is just tile 1. So let me PPU viewer over here. So the Mario dots, all the way Mario.car over here contains all of this, like we were explaining before. And to see the first tile from our names table here, 00 is this. That's why it's repeating right over. Well, oh, this is PPU viewer. Let me just turn this off. That's why all of this is happening over here. This is our Mario from the previous video, this sprite. But what's important over here is our code is actually working right over here. And if I change the attribute over here somewhere, let's see. So this is, let's try this, 00, run test, compile code, Control R over here. I changed this to an actually different color palette over here, so color palette 0. And that pretty much cover all of it. Let me close this down over here. And in the next video, like I said before, I'm gonna cover the how to actually create our graphics and how that works. And let me just open up a few more videos if you got interested more about the subject. Just give me a second. All right, so I'm gonna show you guys some extra resources that you guys can use. First of all, I already have over here NES hacker over here, so make sure you subscribe to him. Hasn't been on for a while, but I know still has good content. And right here under his NES attribute videos over here, explains the whole attribute tables, which is a little bit more targeted ad over here. Sometimes it works, sometimes it doesn't. Not gonna pay a bunch of money for that. Anyway, here is his video. He goes over all the attribute things again. If you guys didn't need a little more explaining, his video shows what I explained. Not only that, it shows here in the emulator showing some pitfalls that happens when with this attribute tables as well. So a little more content material. I always thought about making another video like extra content so you guys can check it out, because I really don't care where you guys learn as long as you guys learn it. So at least a good video content over here to check out. So check out Hacker NES over here. And here is a new guy on the block called NES Hacker. I was looking for this guy over here and I found this new guy happening. A relatively new guy. And he, under this NES Graphics Explain, he does go over all the backgrounds, not only the background data attributes, but as well the sprites. So make sure you come here and subscribe to him. Has great video editing, way better than a lot of guys over here. Pretty much the only competition that he has is like so make sure go to HackerNet over here, probably Retro Machine Game Explain. I'll also highly recommend him. There's a bunch of stuff over here. As you see, I watch a lot, so really good guys. So go over to those channels and subscribe. And at least if you're interested on the NES content of it, go there and check it out. And that's pretty much it for this video. Like I said before, in the next video, I'm gonna go over not only the open here Nerdy Nights, how to create the graphics. So for our games that we want, but how did that work as well? So it's already 30-minute videos. I don't want to make it any longer than it has to be, and that's going to be on the next video. And if you like what I've done so far, please feel free to subscribe, and I'll see you guys in the next video. Thanks, guys, and bye.